So we're solving quadratic trig ratios. So in our very first one, what we can take a look at, we need to isolate for x. Okay. Now we know that, think of these brackets as one term. Okay. This is a term times another term is equal to 0. In that case, we know that one of these terms has to be 0 in order to get 0 as an answer. It's simple multiplication. So we're going to split this. We're going to get root 2 sine x minus 1 is equal to 0, and root 2 sine x plus 1 is equal to 0. Okay. We move the 1's to the other side. We get root 2 sine x is equal to 1, and root 2 sine x is equal to negative 1. Okay. Also, I want you to recognize that this is technically root 2 times sine x. So in order to get to my process of isolating x, in order to move root 2, I'm going to divide by root 2. Okay? Does that make sense? Yeah. So we're going to divide when we move it over to the other side by root 2. So we'll get sine x is equal to 1 over root 2, and sine x is equal to negative 1 over root 2. And finally, because we're trying to isolate x, we need to move sine to the other side of the equation. And when we do that, it becomes the inverse of sine. So we get x is equal to sine inverse 1 over root 2, and x is equal to sine inverse negative 1 over root 2. Okay. Also, our restrictions were to find x when it is between 0 and 360 degrees. Okay, very important. So we're also looking for x when it's equal to, greater than 0, and equal to and less than 360. So we're working in degrees. We're not working in radians for this question, so luckily my calculator is already in degree. Okay, when we go to solve this, there's two ways. And the first way, I'll quickly show you on the calculator. I would actually technically have 1 divided by, in brackets, square root of 2. And then I would use sine inverse. Gives me 45, 0.001. Essentially, it's giving me 45. Now, the other way I could have solved this is if I looked at my special triangles. Okay, I know I'm looking for the inverse. Well, actually, what I'm doing is I'm looking for what this essentially is. And we have, if we were looking for sine x before, so say we were just at this step here. So this is where I moved it to this step for the calculator. But I actually could have solved from the step before it. If we had sine x, and we know that the angle was equal to opposite over hypotenuse, because that's what our sine formula is. So sine is equal to sine x is equal to O over h. With our special triangles on the other page, we would be looking for an angle where the opposite is 1 and the hypotenuse is root 2. Well, that works for both of these angles. So we know that our answer would have been 45 degrees. Okay? So we would have got 45 degrees in this one here. Oh, sorry, let's put that answer below. So we get x is equal to 45 degrees for our answer. Is because we have positive 45 and negative 45. Essentially, sine is positive in the first two quadrants, so I know I have our first option, 45 degrees. Our second option, because it's positive there also, these are both positive signs, so we have 45 degrees when we rotate. We have 90 plus 45 is going to be 135 degrees. So my two positive signs, so we've done the options with that. And our two negative signs is, we know that sine will be negative. So I guess we should put sine positive, sine positive. And then our sine negative, sine negative. Yeah, the exact same idea. Again, we have a 45 degree angle, 45 degree angle, And in those cases, we get, when we come all around, we get 180 plus 45. What's that give me? 325? 225, sorry? 225, yeah. 225. And finally, our last option, if we come all the way around to here where it's negative, 315. So we have 4 answers to this question because we had 2 options for our x. Okay, so 7e, essentially what we're looking at is a quadratic again, and you know, it's not that similar to what we're normally looking at with quadratics because we have trig ratios in there. One way you can clean things up, and we'll do it this way, and if you want me to do it the other way first, what I can do is I'm going to say let, just so it's a little easier for me, let A equal tan theta, okay? So in other words, what I'm going to do is all of my tan thetas, I'm going to replace with the letter A. Minus 2A is equal to 1, okay? So this is important because I eventually have to go back to that. But the only reason I did that is just so I don't have to write as much A, and it's a little cleaner to look at. So let A equal tan theta. So now I'm working with 3A squared minus 2A minus, plus 1, right? Plus 1. If I look at this, I know I can make a quadratic equation set equal to 0. I'm going to move the 1 to this side of the equation. So we get 3A squared minus 2A minus 1 is equal to 0. Now what I'm looking at is something that's possibly factorable. Okay? So remember when we do factors of the first term, factors of the last term. We know their products need to add up to our b term, which is negative 2. So sorry, we have 3A and 1A. So if we do 3A times 1, we'd get 3A, and 1A times 1, we get 1A. Any combination of that equal 2A. Can we add 3A and 1A and get negative 2A? Do you remember doing this stuff?
I'll do it that way.
Did you do decomposition? I'll quickly show you this method. Okay, I guess you've not seen this one. If I had 3 as a negative, negative 3A plus 1A is 2A, so that means I'd make this negative. These will become my first terms. Okay, so when I'd go to factor it and put it into brackets, we would have 0 is equal to, I just brought the 0 to the left side of the equation, okay? And we'd have our 2 brackets. My first terms, I have them right there, are 3A and 1A, or just A. These are my second terms, negative and positive 1. The only trick is, because I multiplied, I should use a different color, 3A and negative 1, 3A and negative 1 have to go in opposite brackets. So if you're not used to seeing this, don't worry, we're going to decomposition now. And plus 1. And the reason that one worked is because we multiplied 1A and positive 1, so the 1A and the positive 1 went in opposite brackets. So essentially we got our answer at 0 equals 3A plus 1, 1A minus 1. Do you want to do decomposition here? Okay. The other way we could have solved this is through decomposition. And I'll quickly go through it, because I think you know it. 3A squared minus 2A minus 1, right? And we're talking about 2 terms that add to our b, which is negative 2, and 2 terms that multiply to our a times c, which is negative 3. Does that make sense? Okay. So what 2 terms add to negative 2 multiply to negative 3? Well, if we had positive 1 and negative 3, and positive 1 and negative 3, we know that works, right? So we split our middle term, negative 2, into those 2 terms. So we get 0 is equal to 3A squared. Negative 2 is split into plus 1A and minus 3A, right? And then we still have our negative 1. So now what I do is I group them. I find the common factor for each of these. So a common factor here is just A. So I get 3A plus 1. And in this one, I kept the negative sign, okay? I'll outside, there is no common factor. It's essentially just 1. So I factored out just a 1 there. Does that make sense? So now we end up with, you know what we needed to do? Because this is negative and this was positive, we needed to factor out -1 right here. So I actually did factor out -1. So that changes our terms. This used to be a -3a. When I factor out -1, it becomes positive, and the other term becomes positive also when I divide by negative. So now what we get is 3a plus 1, a minus 1, which, if you notice, is the exact same we found up there. Okay, so either way works. So what's important now, though, is we had our 0 is equal to 3a. I'm actually not going to rewrite that. What I'm going to do now is I'm going to go back up to the top. Remember, a was equal to tan theta. So I'm going to replace my a's with tan theta now. Okay? So I now get 3 tan theta plus 1. And I get tan theta minus 1. Theta minus 1. Okay? Now this goes right back to, do you remember question 5e we just did? This is two brackets that are multiplied by each other. So because they're multiplied and they equal 0, I know one of them has to be 0, so I'm going to split the equation into 2. Each could be equal to 0. 0 equals 3 tangent theta plus 1, and 0 equals tangent theta minus 1. Okay. I bring the 1 over, I get -1 equals 3 tan theta. The other one I bring -1 over equals tan theta. Okay. This one is a third tan theta, and this is -1 tan theta. So let's talk about some trig. Okay, so using special triangles, quickly draw two triangles here. So this guy here, and in this case, I just happen to know this equation is going to work with that. So we're in radians in this question. So 45 is pi divided by 4. Pi divided by 4, right? And 90. We have a 1 root 2. Well, we're looking for -1. -1 can actually be written as, 1 over 1. And tangent of that would be an angle that is opposite over adjacent. Clearly we get 1 over 1. So tan theta is, because it's -1, is going to be -45. So that's one of our answers. We have not 45, not in degrees. -pi over 4. Okay? That's one of our answers. Does that make sense to you? Yeah. -pi over 4 is what we're working with. Now technically our special triangle is written like this. 60, 30, root 3, 1 squared. Now, if we use a similar triangle, say I decided to, so we have, we were looking for when tangent was negative, because we had -45, -pi over 4, I always call it 45. This is the angle of pi over 4, this is an angle of pi over 4. These are the two quadrants, it's negative. So, in terms of our angles, we should be getting 2 pi subtract pi over 4. And this is 2 pi. 2 pi subtract pi over 4 gives us, oh, you're right, 2 pi is all the way around. Yes, pi subtract pi over 4 will give us 3 pi over 4. 4 gives us 3 pi over 4. And the other one is 2 pi subtract pi over 4. Pi over 4, which, actually I think that should give us 7 pi over 4. Alright, here was our mistake. When tangent came to the other side, 1 should have became positive, which means this is positive, which means we're working with positive pi over 4. So these are the opposite quadrants that we're supposed to be in. Oh, jeez. Silly mistake. Okay. So these are the two opposite quadrants we're supposed to be in because, well, at least we know tangent's negative in those. We actually need when tangent is positive, which is these two quadrants. Let's get rid of these two lines. And we're looking for here and here, which means we have pi over 4. Strictly, that's one of our answers. And the other option is here, where we add pi over 4 to pi. Yeah, exactly. So we change our math a little. One answer is pi over 4. The other answer is pi plus pi over 4, which is 5 pi over 4. So we have our two answers.
Okay.
That makes sense. Okay. So actually, when we went to look at this one, special triangles isn't what we're going for because it's not root over 3. So in other words, what we need to do is we need to convert. We're going to have to do some conversions here. Okay. I'm going to figure out what this is in degrees. So in other words, if I was in degrees, my calculator, and I had negative 1 divided by 3 inverse tangent, hit 18.43. Okay, so that means my theta in degrees, 18.43. So if we have 18.43 as a degree, we can try to change this into our radians. I guess we could round it to 18.5. 18.5 degrees. Now we're going to have to do some conversions with it. Okay, so right now what we're dealing with is we have a negative, we know we have a negative tan, right? And I converted it to degrees because I work best like that and then change it into radians personally. Now what's important here, because we have negative tangent, that means we're in the other two quadrants. So we have something like this and something like this. Okay, so I'll start off with in degrees, but we'll change it to our radians after. Right now, this is going to be our 18.5 degrees, and this will be our 18.5 degrees. Okay, so we have those two measurements. So we're going to have to find this angle, and we're going to have to find this angle. Those are the two more angles we're going to be looking for. So on our next page, our original one is pi over 180 is equal to radians over degrees, right? I quickly moved it over here. Our degrees were 18.5, okay? Times pi, I plugged it in for the degrees. Now, I wanted a whole number because I don't want to work with a decimal, so I multiplied both the top and the bottom of this by 2. I multiplied 18.5 times 2. We got 37, and 180 times 2 is 360. So now I'm working with whole numbers. So my radians are 37 pi over 360. Okay, so back on our other page, what that means is this is 37 pi over 360 as an angle, and that one's 37 pi over 360. Does that make sense?
Yeah.
So those are those two. Now we have our radians, and because we had to subtract from pi, our answer, from pi and pi 2, because we're in the other two ones, I didn't show it here, but what I did is I turned this into 360 pi over 360 pi. Sorry, over 360.
Yeah.
I subtract it and got that as one of my answers. And in this one, I changed this to 720 pi over 360, and I subtract my fractions. Yep. Those are your two answers in the back of the book. They equated them, but if your teacher wants your stuff in radians, that's what she wants as an answer. Okay, question 8a. They have secant times cosecant minus 2 times cosecant x is equal to 0. I'm going to do two let statements. Let a equals cosecant x, sure. And let b equal secant x. Okay, so what I'm doing now, and I will leave them in those colors, that's fine. Secant is now b, so I have b times cosecant is a. minus 2 cosecant is A equals 0. So essentially I have AB minus 2A does not equal A, equals 0. Well, looking at that, very easy to see. I can factor A out. A is equal to B minus 2 equals 0. Now, as far as possible, now I have technically two numbers multiplied by each other. And actually, before I even go back, this is A times B minus 2 is equal to 0. So I know that A is equal to 0. I can split this, okay? Because, again, we have to multiply to get 0. A equals 0 or B minus 2 equals 0. Now that I have that, let's go back. A is cosecant, so cosecant x is 0 or B is secant. Secant x minus 2 is 0. So cosecant is 0 or secant x is equal to positive 2. And then we work from there to kind of solve. So cosecant is inverse of sine, so we get 1 over sine x equals 0, right? Let's move this sign over. If I move sine over, it would say 1 is equal to 0 times sine x. Not possible. I can't multiply something by 0 and get 1, so this is a dead equation here. Our other one, secant is the inverse of cos. So 1 over cos x is equal to 2. Well, when I bring cos over, 1 is equal to 2 cos x, which is now a half is equal to cos x. That's when I bring the 2 over. Okay. 1 over 2 cos, special triangles, adjacent. I'm talking about adjacent and a hypotenuse. That works out perfect. I'm talking about 60 degrees. Are we in degrees or radians?
We are in.
So we know this is
Radians.
60 degrees or pi over 3, right?
Yeah.
So we have pi over 3. Let's figure out what quadrants we're in.
Oh, that way is so much easier.
This way?
Yeah.
So we just do it like this. Okay, so we have positive pi over 3, so we're talking our CAST system, C-A-S-T. Because we're positive, cos is positive in this quadrant, quadrant 1 and quadrant 4, right? So in other words, we have pi over 3, and we have pi over 3. So one of our answers is pi over 3. The other one is 2 pi minus pi over 3, which would give us 5 pi over 3.
Yep.
Those are your two answers.